morning, Professor. This is my personal timetable. In this week, I have planned to implement the 5 tasks. The first task is related to the urine biosensor research. I already have started to write a draft paper as well as to start again experiment for the capacitance measurement, and the new measurement is zeta potential, also looking for at which university or which institution they have facility to characterize the zeta potential measurement. The task 2 is the review paper. Is already I have implemented in the content and also updated the figure as per your suggestion. The task 3 is coronavirus biosensor research. Me and Prashant, we have already started to do the experiment, and also we are successfully done with the antibody and antigen binding, and hopefully in this week we will present you the positive data. The fourth task is AAO biosensor research. Me and Bruce have discussed together to work with the Ag plus protein sample that you given us in the last week, and yesterday we did the immobilization of Ag protein with the graphene oxide to check the wavelength by using LSPR, and Bruce will show you the result. And the fifth is meeting with Jacob to discuss with his work and also to work on simultaneously in a draft paper. So this is the research plan of the urine PSA biosensor that I already shown to you before, so I just skip this slide. And this one is also the same that I already shown to you. It's a FTIR result related with the different kind of antibody. This graph is related with the 1H12 and the second one is AB2218. Actually this is the two different type of antibody related to the urine PSA biosensor research, and we already have the difference between each antibody, and to go with the only single antibody, that is AB2218. And this one is AFM figures. It's a bare surface with graphene oxide and using EDC with the two different kind of antibody with the same antigen. So we got the different kind of surface morphology under 100 nanometer surface. And this one is the SEM Images. It's a 1H12 and the right side AB2218. This image is related with the antigen, like what we got with the antigen molecules. And this is the cross sectional of the sample characterization that I already present this slide to change. We have defined that the PTTI metal is always changed with the biological elements. If we compare with the bare surface, then we compare with the 1H12 antibody, the metal surface is already changed. And if we consider with the antigen, it's also vary the PTTI metal surface. And this one is the water contact angle measurement. I already mentioned here, the angle is always changed as per the solution, as per the sample, and we have got different kind of angle by using a different kind of antibody. 1H12 is having a 61.2 and AB221 at 69.0. In my mind, there is one measurement is also going ahead, because why I am doing, because to check the particle size, conductivity, ionic strength, sample concentration. So if we have the four kind of measurement in a one machine, is a zeta potential machine, then we evaluate the charge stability of a dispersed system, and the measurement also was taken by applying an electrical charge across the sample in a folded capillary flow cells. As you have seen that zeta potential machine is basically to check the particle size, conductivity and ionic strength by using this small capillary cuvette tube. And this one is also the introduction of zeta potential. Short video is already embedded in the PPT. So in my mind, if we do this kind of measurement, then we also have a better modification or better results to justify our research. And this is my research roadmap for the writing papers. For the urine PSA biosensor is, as I told you, we have to start again for the capacitance measurement to making a sample. So it will be done up to the 3rd July. And the draft paper is already started. So the title, abstract and schematic figure will be finished until 2 July, and the introduction and result and discussion will be finished up to 12 July, and the final step, like to submit you the draft paper on 17 July of 2020, and the same for the review article for the 2nd July to implement all the figures and the introduction and the abstract as well, and the final step will be finished until 7th July of 2020. And this is the research plan for the coronavirus research. It's the same pattern, it's the same format for the PSA, but we have to change the antibody and antigen as per the research methodology. And also we have to focus the instruments for the characterization is capacitance measurement, AFM, SEM, water contact angle, and the one more thing is zeta potential measurement as well. So as I discussed with the Bruce, that we have the AG protein sample, so we just make 3 kind of cases to check with the LSPR. First we have to activate the surface by using piranha solution, and then disperse of graphene oxide via spin coating method, and then wait for drying, and then we immobilize AG protein in the 3 different kind of cases, like graphene oxide, AG protein sample, and the graphene oxide AG protein with the DI water, that is mixed with the AG protein, and the third one is mixed with the ethanol. It's simply to check the which suitable, either we have to take in the crude sample or the mixing with the DI and the ethanol, and then we check the LSPR measurement. The Bruce will present you the result because he did yesterday, and hopefully the result will be come out in a different kind of manner. So this is my paper writing plan for the urine biosensor that I already told you, my research mode roadmap. Thank you, sir.